Welcome. Hello, everybody. Can you see me? Hello. Welcome to week 3, session 2. Hello, hello. Let's see, 31. We're still waiting for the boys, I guess. I just sent a message to the boys and I forgot to send it immediately because there's so many options to tick. Let's see. Definitely they're not here. Let's see. Share screen application, share. Give me a second. I need to contact them. Here we are. I need to resend it. It's terrible. Edit. And see if this works. And let's do it again. All right. Wonderful. And we are in. Okay. Okay. Right. Prayer time. I'll see you in 7 minutes. Sounds good. Perfect. Right. And today we'll talk about Alexa, set timer 5 minutes.
5 minutes, starting now.
And Alexa, play Bossa Nova. Alexa, play Bossa Nova.
Here's a station you might like, Bossa Nova on Amazon Music.
Alexa, stop. Alexa, stop. Ah, okay. Testing, testing, 1, 2, 3. All right, is everybody here? Are you back? Great, wonderful. Is the poll still going on? Yeah, no? All right, wonderful. Okay, are the boys here? Yes, good. So welcome everybody. Again, week 3, session 2. Today we will talk about, that's right, Jacob's law, and if we have time, about Miller's law, and if we have time, about Don Norman, great guy. Before we proceed, you have a homework submission. Anybody would like to share results about the Fitts or Hicks law, a calculator exercise? Any volunteers? Comments? Yes? No? No one? Okay, good. Another thing, yeah, there's some confusion about the messages. So these two classes, these two sections should be merged in one, supposedly, and they're not in the system, and that's why you get this message that the class is face-to-face, because the number of students is less than 33 in each section. But yeah, so anyway, we'll trying to talk to the IT people to fix this, so don't worry about it. Another thing, we have this amazing poll on Slack. If you can answer it, it's anonymous, so it will help us improve. And this is the book. You have it on, again, posted the book. You have it here. I could not find the 5th edition version. If somebody has it in PDF, please send it, share it on Slack. And then you also have here the Jon Jablonski book, which we are following in the first weeks because it's better than the equivalent chapters of the official book. Sounds good? All right. How's the submission going? Is it on track? Did you submit? Do I have to do a poll for this? Yeah. Submitted homework 2. Okay, good. Nobody yet. All right. Wonderful. Somebody. Okay, that's somebody. Would you like to share your experience or show what you did? It's only 36 responses. Good. Okay, nice, good. 15 didn't say anything. Right, somebody, no? Okay, do you have any questions? No, fine. Good, so let's go to it. Jacob's law, what is that? Music, suspense. So Jacob's law, here, you can read it. Users spend most of their time on other sites. So they prefer your site or your website or your app or your lecture to work the same way as the other lectures, websites, applications. Do you understand what this means? It, not yet. Okay, good. Okay. So it means that, for example, let's see an example here. Look at this. This is a typical shopping e-commerce website, Etsy, super famous. Totally recommend it. It looks similar to Amazon, right? Vertical menu on the left side, products display images with descriptions on the bottom, ratings on the bottom, some horizontal bar with categories, and the search bar here, and the shopping cart on the top right. Completely arbitrary decision, but because Amazon is this way, if you design a website for e-commerce and it has a different structure, consumers are going to be confused. They will find it hard to use just because it's different. This means there's an expectation of how e-commerce websites are supposed to work. There was no expectation 20 years ago. Now there is expectation because most of the e-commerce websites work the same. Does that make sense to you? Yes. Can you give me an example? Can you type in the chat an example of a similar example in digital world or in real, how do you call it? Real world? Real world, or some metaverse, something. Carrefour, tell me, winner, what about Carrefour?
Can you hear me?
Yes.
If we change it from place to place, like the Carrefour arrangement is the same, all the malls and other areas, so people will not get confused where they can find things.
Okay, do everybody agree with this? Okay. Okay, good. But I noticed that Carrefour changes the location of the things. So I get confused and I spend more time inside the Carrefour sometimes, right? Wonderful. So this law, it's called Jakob's law. Jakob is the guy that founded Nielsen Group. Jakob Nielsen, very important guy. Yeah? So you can read it in this book. And it's a very recent law. It's like 21 years old. I could have invented this law. Right. Okay. It's also known as the law of the internet user experience and so on. Can you give me another example related to apps where two very famous apps have started looking the same? Anybody? I'm gonna start counting. TikTok, 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 TikTok. Yeah. TikTok and Instagram. Very good, Fatima. They completely look the same now. I don't know where I am now. Snapchat, I didn't know that. Okay, cool. Fantastic. Excellent. Got it? So what does this mean from a human-computer interaction point of view? When you design a human-computer interaction system, do not reinvent the wheel unless there is a very good reason for it, right? Yes? Yeah, remember about people dying because they waste time? Yes, so it's the same. Right. Okay, and this is related to the concept of, I'm gonna start drawing on this, my favorite pastime, and today we're gonna use, not sure about this one, mental models. So this has a psychology background, and there's a thing called mental models, and a mental model is a model of the world that you have in your head. It means how you think something works. Most of the time this is correct, right? So everybody has a mental model of how a classroom works, how the university works, what you have to do to get an A you have a mental model, right? And people have mental models about how things work, how to read a book, how to connect a microphone to a USB, how to use an app, how to shop online, right? And these mental models, you can transfer them from website to website. Typical example, cars, right? You know how to drive one car, you don't need to learn how to drive another car, right? They all more or less drive the same, so you can have a mental model for all the cars, which is super useful because it saves time. Wonderful. Right, good. Awesome. And next one. Right. So many of the things that you see on the web today, these are called checkboxes. These are called radio buttons. Do you know radio buttons? I guess yes, right? So do you know why they are called radio buttons? Why they are called radio buttons? Anybody? Mm? Mm, no, well, so before the web existed, there were these things called hardware, electronics. This is a radio power electronics control panel. And here you can see how a radio button looks like from the user point of view, and radio button can be on one side or the other, or can be on or off. That's it. And this is exactly why we call it radio button, because it's the same function, right? And so when the web started and we do these things, these components, people, because they have used these, you never use this because you're so millennials, right? But people realize, oh, yeah, I've seen that before. It's this one. I know how it works. And that's why it's called radio button. And it works like a radio button or a toggle switch like you have here. Switch. Sounds good. This, you can also, it looks like a switch and so on. What about the checkbox? Where does it come from? You have seen this one, right? Because you have done paper tests, right? So you saw the checkbox. So this one comes from pen and pencil metaphor or legacy inspiration. Sounds good, right? So here you have a very good example of how using a mental model can help users that are familiar with something to make it easy for them to use something new on the web. Yeah, very good. Awesome. Right. Totally recommend that you read this chapter. And so what happens when you do something like this? You put a checkbox and it doesn't behave, sorry, checkbox here, and it doesn't behave like a checkbox. You have a thing called mental dissonance. The user is going to be confused because he was expecting, oh, this button to work like a switch. It doesn't work like a switch. And then what? You make him waste 5 minutes trying to figure out what's going on, right? So that's called mental dissonance. This happens, a famous case was this one. Do you remember when Snapchat changed the design? Anybody remembers? Yes, somebody can explain how they felt or experience of the redesign. No, okay. Did you like Snapchat redesign? Nice, interesting. Thiab says it was so bad. Thiab, you can explain to us if you like in the microphone. No? Okay. So the problem with this redesign is that they didn't do it gradually. So it was one day and the next day it's a different design. And then people were used to this design, the previous one, and suddenly, they had automated all these processes, mental models, and suddenly that doesn't work. They still have them, but it doesn't work. So cognitive dissonance, really not a good experience. Many of the users left. Snapchat failed to ensure the mental model of its users would be aligned with the redesigned version, resulting in a discordance caused major backlash. Right, but redesigns don't always need to be traumatic. Google is very good at doing gradual redesigns, and actually they let users try them. So give permission or get permission from the user, opt-in, right? Optional. And that works very well. That's how they have been upgraded their designs. Does anybody remember any change in Google's design? No one. Do you know why? Because they went to JAKob's lectures. That's why. Simon, you do remember some traumatic experience with Google redesign?
I do remember, but it's not like traumatic because the change was gradual, I guess. It's even changing
What
now.
do you remember? Tell us.
In instance, like the search box, it was just kind of blocked earlier, and now it has hover effect and stuff, and more.
You're talking about this one, yeah?
Other features as well.
Yeah, this was how Google was before, but there was never a traumatic revolt of the users like Snapchat redesign. Whereas in Snapchat redesign, man, they lost a lot of money on the redesign. Like I'm talking millions of dollars, and reputation, lots of users. I had the QR code of Snapchat in my office before because all my students were using it. But after the redesign, very good. Okay, wonderful. So anyway, Google very good at doing things gradually, which is good. Here you have another example. Well, you saw this already. Jacob's law. Here you have another example. Okay. Anybody has a Mercedes here? I'm going to do another poll. Hold on a second. Let's see. Polling here. Yes, no. We have a Mercedes. Driver. Right. So the people that have a Mercedes, have you seen this, right? So can you explain us what is this? What is this?
Doctor, this is to adjust, it depends on, like you adjust the seat so you could be more comfortable.
But how do you adjust it?
Yeah, like the first one, the small one, adjusts the head.
What do I touch it or how? I push it?
No, you just it's like a joystick.
Like a joystick.
You move it down and
Interesting.
up.
Do you think this is a good design?
Actually, yeah, and especially that the numbers 1, 2, 3, and M are like
is that?
settings. Yeah, like
Oh, really?
Option 1, you can let's say there are 3 people who ride the same car, so each one have their own way of adjusting the seat, so they save it to each number. So
Wow, that's very cool. And what's the M for?
I have no idea until now.
Okay, bonus point whoever finds out what's the M for. Okay, I would say maybe M is a failure of design of human-computer interaction from Mercedes, because I don't know either what is the M for. This is a brilliant design, right? It's so obvious. Like the first time you see it, maybe you spend 5 seconds, right? Trying to figure out. After 5 seconds, you'll learn it. This is fantastic. This is a very good design. This actually, it's called an affordance. An affordance is a physical metaphor used in a different context, right? So this is a miniature seat. It's a metaphor of the seat. You move one part of the seat left or backwards, and then the seat moves backwards. It is 10 out of 10 for usability. Fantastic, right? You don't need manual instructions, nothing. It's good. The M, what is the M for? Nobody knows. So the only failure maybe it's probably the M. Wonderful, great. Questions about the Mercedes manual? No, I don't think so. Somebody can find out what's the M about. Let me know on the Slack channel. Right. Another very important thing that you should know. Are you familiar with these user personas? No. Okay. So if you take the course for Master's Web 654, Human-Computer Interaction and Usability, or you take the Agile CSBP316, you will learn about personas. So basically, a persona is a piece of paper where you have a fictional user with complete biography details, hobbies, everything. And then you give this to the web designers and you tell them this is the typical user of the website, and they have this in front of the desk. And that helps them remember that who they are designing for. And that helps everybody keep focus. Okay, my designer is a 32-year-old guy, early adopter. Okay, so that's that. Then you know what's the optimal design, or at least you have a direction. Whereas if you don't do a persona, you maybe sometimes the coders, designers forget who they are working for or designing the product for, and you can imagine that's a very bad idea. User personas are super important in many fields: UX, Agile, and human-computer interaction, and it's good to know what they are. Right, wonderful. Right, great, good questions about Jacob's law. I think you got it pretty figured out. Memory, yeah, but how does it work? Like, how does it work?
Can I speak?
Yeah, absolutely, winner.
It's Simon, actually.
Simon.
All right, yeah.
Simon,
I just
where
video
from,
from
Simon?
YouTube. Excuse me.
Where are you calling from?
I'm here in the hostel.
Wonderful. Okay, go ahead.
All right, like I just checked a YouTube video explaining about the thing we were discussing, and there is some setting down there around the seat, and after setting the mirror and some stuffs in the car, I'm not actually like familiar with, and after setting that, the memory button, like we press the memory button, and then there's 1, 2, 3, we press them one after the other. This lets the system to remember. That means like saving stuff. So that's the purpose for M button.
Oh, to set the memory.
Yeah.
Right. Interesting. It looks quite complicated, right? I would rather be that you press the number 1 for 5 seconds and it gets stored in memory, right? Like the radios. But anyway, good. Thank you. That was very useful. Thank you very much. Okay, now let's go to the next very important concept for today. It's called Miller's Law, and it's related to, let's see if we can find it. Miller's Law, yeah. Right, so I have a game for you. Okay, can you look at this number? Got it? Got the number? Okay. Now, I'm gonna give a bonus point to anybody that can type the number correctly in the chat. Type the number, 9 figures. See what you get. If you get it right, you get a bonus point. 1, 2, 3, go. You have 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Time's up! Time's up. Stop it. That's it. Alas. Okay, let's see who got it right. Almost. Fatima got the first 4 well, and 6, 7. Fatima, you got 1, 2, 3, 4, 5, 6 correctly. Amazing. Very good. They take picture. I know, but they're not so fast, right? So anyway, nobody got it right, as I can see. But somebody got 6 numbers right. Okay, so if you do this experiment with your friends, you will notice that most people, or you will notice a magic number, 7. Like nobody remembers more than 7 numbers of the numbers you show them. And why is that? And also, why the rainbow has 7 colors and not 9 or 20? Anybody can answer this question for me? Like why, right? Like, work here? No. Yeah. Yes. Why does the rainbow has 7 colors and not 9? Because it's the only colors we can see. Absolutely incorrect, said. Definitely not. Because there are 7 colors. Yeah, that's a question. Why there are 7 colors? That's what I'm asking. Yeah. Why there are 7 colors and not 5 colors? Did you ever think about that? No, that's Fatima, no. Why there are 7 colors and not 9 colors? Color space. And remember that colors, this is all the colors in the world, kind of saturation wise. So we have decided that we have 7 groups, but we could have made 9 groups or 20 groups. Yeah. But no, 7. And you will see 7 repeating in many other places, like 7 magic tokens, 7 Dragon Balls, and so on. So why is that? Why is that? Did you ever think about that? What people are saying? It is by convention, but don't you think it's weird that all the cultures in the world, including the tribes in the Amazonas, they have 7 colors? Yeah, 7 seems to be a magical number. Why is 7 a magical number and not 6 or 8? Did you ever think about that? Somebody tell the right winner, because there is a limit of our short-term memory, and we want to keep. Yeah, that's actually correct. No, it's not. Right, look at this. Super important law. Okay, it's called Miller's Law. The average person can keep only 7 plus minus 2. So some people can only remember 5 things, okay, in their working memory. That means at the same time. Do you get it? Wow, that's very interesting. 7 people at the same time cannot remember more, cannot juggle. It's like the processor, the CPU of our brains has only 7 registers if you took microprocessors. And that's why. That is the reason why there are 7, exactly 7 colors and not 8, not 9, 7, because it's very hard to remember. And that is why 7 appears in many discussions about how long should a menu be, or a list be, or you can imagine that with this limit, if you don't take it into account in your design, it may be a disaster. I'm going to show you a very good here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, okay. So this is an illustration of the memory size or limit of our brain, and basically it means that when you ask the user to do a task, for example, here you have an example, and this is real. This is real thing from America, okay? But you see people that improve their remote controls, and you can count the number of pieces they left out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, and this big one, right? And this one here, right? And here you see 1, 2, 3, 4, 5, 5, 6, right? There's not 20. Does it make sense? And this has implications. For example, if you have a menu like print, if you need the user to do a task called printing, so I need to remember a few things. First, I need to go to the menu, press file, so menu, file, then press print, if I don't remember the shortcut, right? So I need to know 3 things basically at the same time, right? If you design a software or a product or a process where to do a task, the user needs to remember more than 5, 6, 7 pieces of information to accomplish the task, then you're really overloading the memory of the user. And then the user will feel stress, and it will not like using your product. And so keep in mind this cognitive limit that humans have. We're very good at some things, but short-term memory, we're terribly, terribly limited. Questions about this one? The computer as well, but the computer, I think, can somebody tell me how many short-term memory we have in the Apple M1 chip? I think it's like 8 megabytes, right? So that's our El Cache one, right? El Cache one, most important memory. 8 megabytes is pretty not bad, right? So that's what, like 4 million variables, more or less. Short memory, pretty good. Right, fantastic. Yes, questions about this one? This is so funny, isn't it? You have an example of card sorting that we mentioned the other day. And so that's why. So how do we overcome these limitations? So one way is to convert these 9 numbers into 3 numbers. And this is called chunking. So if you, instead of presenting the information as 9 chunks. Chunk it, you means group into less than 7, in this case 3. It might be easier for the user to remember because we have this capacity of chunking, and chunking means making groups. So if you remember, the first chunk is 440, sorry, and the second one is 867, and the second one is 4309. 3 chunks, okay, 440, 8307, 4409. Wow, suddenly it's much doable task than remembering 4408675. Let's get it. Chunking. And chunking, you can see it happening in menus, right? And in many other places, like for example, websites. Here you have an example of chunking where they group. There's a lot of information, but they did a hierarchical grouping. So even though there's a huge amount of information in this page, it's grouped and organized. So we just see 1, 2, 3, 4, 5, 6, 7, 8 things, and then we don't feel super mega overloaded. Whereas if they had displayed this information like this, the users would go mad. Sounds good? So this is called chunking. Yes, questions? Mm-hmm. Where are you? Right here. Salama says, this helped me memorize my email ID by keeping looking at the PCR text. Wonderful, Salama. Excellent. Great. So that's fantastic. Next on list. 7, right? So if you look at most e-commerce websites, they try not to overload you. They don't display more than 7 products at the same time because they know that doesn't make sense. You know, they try to respect this rule. Here, you know, 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5. 1, 2, 3, and here they didn't respect it, but kind of 1, 2, 3, 4, 5, 6, 7, 8 groups. Yeah, sounds good. Not 10, not 20. Wonderful. Got it? This magical number 7, and here you have the explanation about why the rainbow has 7 colors only. It's a cultural construct. Okay, good. Questions so far? No questions? Good, excellent. Now let's watch a guy called Don Norman. Anybody knows Don Norman or has heard about Don Norman before? No? Okay, good. So we want to watch a 5-minute video. Yeah, super cool. Let's see. Somebody saying something? Yeah. I don't think so. Okay. So Don Norman is a very famous person because he has very good ideas about usability, UX, and so on. In fact, if you look at the logo of this Nielsen Norman group, he's the Norman here, right? Okay, are you ready for this amazing video? Let's see. I don't know how to.
You're goddamn right.
Wow, okay. Maybe I should reload the page. Let's go.
There's this door.
Can you hear the sound? Wonderful. Okay, let's go. Ready.
Door
Go.
on the 10th floor of the Vox Media office that I hate. There's this door on the 10th floor of the Vox Media office that I hate so much.
God damn it.
you ever get this door wrong?
Pretty regularly.
Have you seen people misuse it?
All the time, every day. Constantly. I hate this store.
Me too, Kelsey. But here's the thing. As soon as you start looking for confusing doors, they are everywhere.
It's push.
Why? I feel like Roman Mars would know about this.
This is 99% invisible. And those doors you hate are called Norman doors.
What's a Norman door?
Don Norman wrote the essential book about design. He is the Norman of the Norman door.
All right, and where is this guy?
You must go to San Diego.
Okay. Hi, Joe.
Hey, I'm Don Norman. Gee, you know, it's hard to describe what I am.
Well, he's been a professor of psychology, professor of cognitive science, professor of computer science, a vice president of advanced technology at Apple. But for our purposes,
I was spending a year in England. I got so frustrated with my inability to use the light switches and the water taps and the doors even, that I wrote this book.
If I continually get a door wrong, is it my fault?
No. In fact, if you continually get it wrong, it's a good...
Right. Question, what is a Norman door? Who can tell me? What is a Norman door? Can you be more specific? With any description. A door you hate, frustrating door. You're so emotional, right? Very emotional. A bit more description, please. A door with a bad design. Interesting. Okay, let's continue with the video. Good. A door any door that's confusing. Door where you don't know to push or pull. Huh.
If other people continually get it wrong, good sign that it's a really bad door.
Okay, let's see what he says.
Good sign that it's a really... And if other people continually get... In fact, if you continually get it wrong, it's a good... And if other people continually get it wrong, good sign that it's a really bad door.
a Norman door is one where the design tells you to do the opposite of what you're actually supposed to do.
Wow, the opposite. That's a Norman door, okay? Opposite. Wow. It's like a question in a quiz, right? It's designed to make you fail, right? Is that true? But how? Let's see how. Okay. No, it's not true. Quizzes are designed to test you.
Or gives the wrong signal and needs a sign to correct it.
Why does it need an instruction manual? That is, why do you have to have a sign that says push or pull? Why not make it obvious?
It can be obvious if it's designed right.
There are a couple of really simple, basic principles of design, and one of them I'll call discoverability. When I look at something, I should be able to discover what operations I can do.
The principle applies to a whole lot more than doors.
Wow, okay, what did they say now? Super important thing. What was the keyword? Principle of the, and what is that? It's the opposite of I need to read the instruction manual to understand how it works, right? It's the opposite. Yeah. So if the product is discoverable, I mean, I can learn like a kid. I can learn how it works without too much trauma. You would be surprised how many machines don't use this principle and they're terrible. Do you have an example of a very famous machine that it's very bad at that?
And it's amazing with many of our computer systems today. You look at it, there's no way of knowing what's possible. Should I
Right? It's like, it's incredible.
tap it once or twice or even triple tap? So discoverability, when it's not there, well, you don't know how to use something.
Another is feedback.
And so many times there's no feedback. You have no idea what happened or why it happened.
And these principles form the basis of how designers and engineers work today.
Got it? You got that? discoverability, and feedback. If your interface doesn't have that, you'll get a 0 in the course.
Commonly known as user or human-centered design.
Also very important keyword, human-centered design is another way to say that in a fancy way.
I decided at one point the word user was a bit degrading. Why not call people people? And it's amazingly simple and amazingly seldom practiced. We call it iterative because it goes around in a circle. We go out and we observe what is happening today. We observe people doing the task. And from that, we say, oh, we have some ideas. Here's what we should perhaps propose to do.
Then you prototype your solution and test it.
Quite often these are wrong at first, but each time we go around the circle, we do a better job of making the device until the point we're actually making something that really works.
And this process has spread all over the world.
And it turns out it's improving lives.
From better everyday things like the ones that Don wrote about,
to using the same process to solve huge problems in public health in developing countries.
water,
Sanitation,
farming.
lots more. So what'd be a better human center for?
An ideal door.
Question for you, what would be a better door? Of course, it's easy to criticize, but how do you make a better door? Anybody has any idea? Suggestions? Automatic door. Yeah, but those are expensive. But yeah, nice. Or, I mean, Mariam, you mean those that I have to go there and wave to the door and then it doesn't open? Those ones? That's why you have a door, because you don't want it open for many, many, many reasons. Like, why do you have a door in your house, right? Or in the toilet? One handle, okay, that's interesting.
Is one that as I walk up to it and walk through it, I'm not even aware that I had opened the door and shut it. So if you had a door which had a flat plate, what could you do? Nothing. The only thing you can do is push. Because see, you wouldn't need a sign. A flat plate, you push.
This kind of push bar with the piece sticking out on one side works well too, so you can see what side you're supposed to push on.
The vertical bars could go either way. A simple little hand thing, though, sort of indicates pull.
But we still have terrible, terrible doors in the world. So many of them.
There are lots of things in life that are fairly standardized, and therefore, whether I buy this house or not is not a function of whether it has good doors in it. And so, except for safety reasons, doors tend not to be improved.
But the tyranny of bad doors must end.
I think that it's a really shitty design. In fact, they put a pull handle when it's a push. And it should be a flat panel right here. And not a pull handle. That's how I feel about this door. It's very misleading.
I agree.
You're right, Becky. You're goddamn right. And if we all thought like you, well, we might just design a better world together.
It won't open because it's a security door.
Right, and that's all about doors. How did you like this one? It applies to software as well, by the way. Hilarious. Well, you can watch it by yourself. The end is very dramatic. This is from the movie Snatch. I'll share this video later. Yeah. The point here is that there's a lot of software and machine and interfaces that are so poorly designed. My goodness, it's incredible. Blackboard is an example. I was counting the other day how many clicks I have to do just to start a session here, and it's more than 15 clicks. It's madness. So yeah, very poor designs everywhere, and that's why you are here in this class. Good. Okay, so we'll stop here. There's a lot of content to unpack. I'm gonna give you, that's it. I'm gonna give you one assignment. So your assignment is to find the worst UX fails. Okay, so if you go to the internet and you find UX fails, you will see examples, very good examples of really bad designs, and that we can learn a lot from them. And so try to find an example of a terrible usability design. How do you know that a design has failed? Usually is when users add post-its to explain how things work. For example, this is French. It means light is this one, and this must be the alarm probably. And somebody got tired of listening to the alarm and decided to put this. This is a failure, right? And so looking, this one is another example. Supposed to be an elevator, but what are you supposed to press, the button or the arrow? Or it's ridiculous, but it's real, by the way. This is another example, and so on. So find the most hilarious and submit it. I will create a task and submit it, and then the next day volunteers can, wait, not this one. Volunteers can explain. This is another example. Elevators are really funny. We will review the best UX fails. Sounds good. I think this is Dubai. Okay, good. Here, look at this one. ATM machine. The employees had to explain where to put the coins, where to put the credit card, because people were getting confused. Right. Questions. Okay, take a picture and share it. Oh, you cannot see. Oh, I'm so sorry. You cannot see what I'm sharing. Well, then, sorry about that. I was having so much fun by myself. If you Google, I was saying, if you Google UX fails, you will see a lot of UX failures, things that are not very well designed. Like I was saying about this ATM machine. So a sign that some user design is very bad is that when somebody had to put labels to explain what each thing is. In this case here, somebody had to explain that this is where the money comes out, this is where you put the credit card in, because people were putting it the wrong way, right? So when you see, and this one also, this is a Otis elevator, right? Where do you have to press? In the light or in the arrow or where, right? So good, excellent. So I'm going to create an assignment. Here's another example. Push. Somebody had to put this push because Norman door. So find some failures. Try to make it real. This is a joke, so that's not a very good example of a UX fail, right? Try to find an example that you like. This is a very good example. Typical, by the way. Somebody designed something, but actually the users, this design is so bad that the users make their own path. It's a very good example of UX fail. And so on. Sounds good? So try to find one that you like, that you think it's a good learning experience. Try to avoid jokes. Try to find a very good... this is another UX fail, right? So very funny. Pinterest, a great source. Questions? Right. I will create an assignment, homework 3, H3, and you can submit it there. It's gonna be by group again. Sounds good? Questions? Everybody has questions? You can make a small video explaining it if you like, and so on. Okay. So I see everybody's here. Congratulations, 55. That's a record. Full house. What else? We should do a quiz next week. When would you like to do the quiz? Monday or Tuesday? Yeah, the quiz is online. Yeah. Lockdown browser, 10 questions, true, false, multiple choice. Right. So we'll do it on Tuesday. Sounds good? you should study all the videos we have and do the homeworks and review the laws. And so you have all the materials in the Dropbox. So you have a book here. So read the 4 laws that we have seen. You can rewatch the videos. Yeah, so read the book. Read the PDFs. You have the PDFs ordered here, but week 1, week 2, week 3, everything. You have the exercises, submit the homework. Sounds good? Yeah, so today you may want to read this in depth. Read the book. We can't see the screen. Oh, really? That's weird. Really? Mm, 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 mm. Really? Which one? Can you send it to me? Because sounds. Let's see. You're talking about this one, yeah? Is this true that you can only see the screen? Because here I see the screen. Is this true? Let's see. This is not our course. Let's see this one. No, I can see the rest, no? Here, I can see the rest. And here, no, I can see everything. Right? This is Higgs law. No, I see everything. Why do you say that? Okay, anybody else has a question? Maytha, talk to me later if you still have this problem. All right, good. So Tuesday is gonna be it. Awesome. You may now leave. Right, good. Wonderful. Okay, so have a great weekend. Read the book, practice the homework, Higgs law, Fitts law, the formulas. You can find previous quizzes from the last years in Dropbox. Awesome. See you soon. Ciao, ciao. Have a great day. Bye. Very good. Ali Said, are you here? Attendance, everybody's here. It's done. Somebody wanted to talk to me. Okay. IT service, e-services. Yes, you may leave now. Okay, CSBP. $28. 50 is done, and now what else? G602 also needs to be done. Oh no. That's terrible. Bad. Oh no. Oh no. Oh no. It's gone. Research.